In this example, we're just going to verify that the circuits that we've designed are going to give us the correct correct results in several cases. Here, we're going to look at a half adder circuit, and we're going to say that both A and B are going to contain 1. So I'm going to see that A is 1 and B is 1. And then I just want to verify that those are going to give the correct results. I know that if I see an exclusive OR is looking for the two results to be different from each other. But in this case, the two inputs are the same, and therefore the exclusive OR is going to give a 0, and therefore S is equal to 0. But the AND gate right here would like for both of the inputs to be 1, which they both are, so therefore this result is 1, and therefore carry out is 1. Well, that's what the circuit is giving. Let's see if that's correct. If I do this arithmetic in binary, I'm going to get 1 plus 1 is equal to 1, 0 in base 2. Of course, we know that that's just equal to 2 in base 10. And when we look at this number 1, 0, the right-hand result is the sum, and the left-hand bit, that's going to be the carryout. So I expect a carryout of 1 and a sum of 0, carryout of 1, sum of 0, I get the correct results. Let's consider what happens if A equals 0 and B equals 1. Well, then I get a 0 and a 1, and I get a 0 and a 1. The exclusive OR gate is now happy because the two inputs are opposite of each other, so therefore that yields a 1 and S equals 1. 0 ANDed with 1 is going to give a 0, and therefore carryout is equal to 0. 0 plus 1 is equal to 1 in binary. It's probably good to go ahead and indicate that as a 2-bit number. Let me try that again. This will be 0, 1 in binary, where this result is the sum, and this result is the carryout. And sure enough, I do get a sum of 1 and a carryout of 0. There's probably not going to be too many startling surprises on this exercise, but I just want to give you an opportunity to see that the circuit diagrams are doing what they're expected to do. What happens if it's A equals 1, B equals 1, and carry N equals 0 for the full adder? Okay, now in this case, we have the 3-input exclusive OR gate, but that's really the same thing as a 2-input exclusive OR gate followed by another exclusive OR gate bringing in the third input. Well, let's see, if A equals 1 and B equals 1, well then this exclusive OR gate is going to yield a 0. That'll be an input to the next exclusive OR gate. Carry N is also a 0. Those two results are equal, so that's going to generate a 0, and therefore S is equal to 0. Looking at the bottom part of the circuit here, I see that carry N is a 0, so that's going to go there. And then actually the result A exclusive OR B is a 0, so that's going to go here. And then I can see that the other two are going to be a copy of A and a copy of B. Well, clearly 0 and 0 is going to yield a 0. 1 and 1 is going to yield a 1. And if I OR those two together, I get a 1. So therefore, carry out is a 1. So if I have 1 plus 0, that gives me a 2. 2 in binary is a 1, 0, where that's the sum and that's the carry out. So I expect a sum of 0 and a carryout of 1, and I do get the correct result. And then finally, looking at the fourth example here, what happens if they're all 1s? So there's a 1, there's a 1, and there's a 1. Well, the inputs to this exclusive OR gate are the same, so therefore it's going to generate a 0, but that 0 is then going to be combined with a 1, because carry N comes directly to the second exclusive OR gate. It kind of gets a bye through the first round. 0 exclusive OR with 1 gives me a 1, and therefore the sum is going to be 1. I'm going to bring the carry N down to here, and I have a 0, which comes directly from A exclusive OR B, and then copies of A and B come down here. 1 and 0 gives me a 0, 1 and 1 gives me a 1, 0 or 1 gives me a 1, and therefore carry out is equal to 1. And if I consider the actual result, 1 plus 1 plus 1 in binary will give me a 3, which, whoops, that's not tertiary logic, that's binary logic. And that's 1 plus 2 is 3, so therefore this is going to be the sum bit, this is going to be the carry out bit, and I expect a sum of 1 and a carry out of 1. And at least for these 4 cases, these two circuits are definitely yielding exactly the correct results.